Hello students of class 9. Welcome to my channel Chemistry by ANR. I'm going to deal with the first chapter of chemistry, which is about matter. Do you know what is matter? Matter is anything that occupies space and has mass. If you have thought it correctly, then yes, you are done with what is matter. There is a dialogue which I often say to my students, so I am sharing to all of you. All that matters may not be matter, but matter matters. Why? Because matter is very important for us. Whatever we see is made up of matter, is made up of particles. So how many states of matter are there? You will say, ma'am, there are so many states of matter. Yes, you will say, ma'am, there are solids, liquids, gases, plasma, Bose-Einstein condensate, and so many more. But keep in mind, there are three main states of matter. That is solids, liquids, and gases. If you talk about plasma or the ionized gaseous state which has free electrons, yes, that is also a state of matter, but we are going to deal with three main physical states of matter: solids, liquids, and gases. In these states of matter, we are going to deal with their physical properties. What are the reason behind the properties? And can we change one state of matter to the other? How can we do so? What are the conditions under which we can do so? And many more. So let us explore. Hello class 9. So matter in our surroundings. That is what we had started with. So what is matter? Anything that occupies space and has mass is known as matter. So matter is anything that occupies space and has mass. So it can be air, it can be petrol, kerosene, ice, milk, wood, chair, desk, pen, pencil, any object. Okay, but I said any object. I did not say any sentiment, any emotion. So matter is something that can occupy space and has mass. Based on its properties, it can be classified as physical properties and chemical properties. Physical properties means its existence. It can exist as solids, liquids, and gases. And chemical properties means its behavior. That is, it can be classified as elements, compounds, and mixtures. So I can say that matter is classified as physical properties. Matter has physical properties, one, and the other is chemical properties. So under physical properties comes solids, liquids, gases. Under chemical properties comes elements, compounds, and mixtures, which we are going to again discuss later on. Okay. Now, matter is made up of particles. Particles make matter. That is, tiny pieces or particles. These particles can be atoms, can be molecules, can be ions, whatever is the entity, but they exist as particles. And these particles are in constant motion. They are in motion. These are the two things about matter, I will say. That it is made up of particles and they are in constant motion. So first, anything that occupies space and has mass, and it is made up of particles, and these particles are in constant motion. So what are the evidence of these motion of the particles? Did we see making of syrup? Did we see mixing of particles like diffusion of potassium permanganate in water? Do you know what is the color of potassium permanganate? Potassium permanganate is KMnO4. This is potassium permanganate. Now what is its color? It has purple color or pink color, but when it is dissolved in water, That means I am dissolving the solid in a liquid. KMnO4 or potassium permanganate is existing as a solid and I am dissolving the solid in a liquid. That is what is happening here. And the entire liquid is what? Water. We know water is colorless. So when we dissolve potassium permanganate in water, the entire liquid gets the color of potassium permanganate, that is pink. So this is an evidence that the solid particles of KMnO4 or potassium permanganate has actually occupied the interparticle space of the liquid. Because then you may think, did the entire solution become KMnO4? Yes, we will say it is a KMnO4 solution, but it contains KMnO4 as well as H2O. So what is the color? Color that is attained is of KMnO4 due to the particles intermixing with the particles of water. So this process is based on diffusion and the experiment is based on diffusion. That is intermixing of particles. What is diffusion? Diffusion is intermixing of particles. Now these particles will intermix on their own without any external factor. If I don't stir it also, I will see that it is intermixing. Of course, if I stir it, the process may be fast. But if I don't stir, then also after some time, the entire solution will become purple or pinkish. Now, this is also an evidence of Brownian motion. What is Brownian motion? That we will see. So, these are the experiments like dissolving of a solid in a liquid. Especially if the solid is colored, then we can visualize the change. Mixing of two gases, movement of pollen grains in water. These are the evidences that matter is made up of particles. Now, this figure 2, we have seen the dissolving of colored solid in a liquid. Next, matter is made up of particles which is constantly moving. So yes, since potassium permanganate particles were constantly moving, the entire solution became pink in color. So we can see the pink color is gradually spreading here and finally all the solution becomes pink or purple in color. Now, both potassium permanganate crystal and water, they are made up of tiny particles. Then why the entire solution is not becoming colorless but it is becoming colored? See, when one is colorless and the other is colored, what happens is the color spreads to the colorless area, right? Here spreading means what? The potassium permanganate solid particles, they will occupy the interparticle space of water. What happens when you dissolve sugar or salt in water? You say it got dissolved. After it got dissolved, can you see the sugar or can you see the salt? So where did it go? It is present in the water, but it has occupied the interparticle space of the liquid, that is water. So here we can see purple colored particles of potassium permanganate spread throughout water, making the whole water look purple. So on dissolving particles of potassium permanganate, what happens? They get into the spaces between the particles of water. This is what I have just now explained to you. Now this is the other diagram which represents how the potassium permanganate particles is occupying the interparticle space. Here is it, interparticle space. So it is happening on its own. It's happening on its own without any external stirring. Yes, I said that if I stir it, the movement will be faster and the phenomena will be faster. So what we can conclude as the particles are moving or they are in motion. This movement of different particles amongst each other or intermixing of particles and finally forming a uniform solution, maybe of gases, maybe of liquid or maybe of solid in liquid, is known as diffusion. And this example, the next example is sugar dissolving in water. I have told you, where does the sugar go? The sugar doesn't go anywhere. Where does it go? It breaks down to small particles and finally occupy the interparticle space of water, the liquid. And we say it has got dissolved. Even if we don't stir it, the sugar will dissolve in water, but maybe the process is slow. If we stir it or if we heat it, the process may be faster. So stirring or heating the solution may make the phenomena faster, but if I don't stir or don't heat, doesn't mean that the phenomena will not occur. The intermixing of the particles will not occur. Yes, it will occur. Next, mixing of two gases. See, air is containing what? It containing many components of gases. So we can say it's a mixture and it's a mixture of gas. So to just demonstrate this, we have this type of experiment, diffusion of bromine vapor into air. Bromine gas is having a reddish color. So you have taken two jars. In one of the jar, you have taken bromine gas, and in the other jar, it is just air, colorless. Now, what is happening after some time, if you don't keep any gap in between, then there will be diffusion of the vapors of bromine and it will give you reddish brown color throughout. That means you will see throughout from top to bottom it has become a reddish brown color. Same thing will be observed if I take iodine vapor. Iodine vapor is a purple color vapor, violet color vapor. Okay, violet color is a more prominent color for iodine. So if you take iodine in place of bromine, then the jar will be containing, both the jars will be containing this violet vapors of iodine. Now this phenomena is known as diffusion. It is known as diffusion. And diffusion we have seen in solid in liquid, KMnO4 in water, sugar in water, that was also diffusion, and two gases also diffuse. So this is diffusion or intermixing of gases. Now here we can see that if the bromine vapor is spreading out, it's spreading from a lower jar to the upper jar. And finally, the entire jar is containing vapors of bromine. Actually, did the vapors of bromine increase its volume? No, the volume did not increase. I did not add any bromine vapor from outside to it. What has happened? It has just got uniformly mixed up in the two jar, distributed in the two jar. Now you may think that, okay, it's moving against gravity. How is it so? We know from Newton's experiment, the apple will always fall down. So how can this bromine go up? Yes, it is going up because it has sufficient energy. It is having sufficient kinetic energy, which allows it to move up, overcoming the force of gravity. So this proves that the particles of bromine or the particles of air were in constant motion. And due to this constant motion, moving particles, the energy that is attained is a form of energy which is known as kinetic energy. The energy on account of movement of particles. And due to this energy, it possesses sufficient, I'll say, energy in order to overcome the gravity. So it overcomes the force of gravity and goes upward. So the upper gas jar also diffused downwards. So there is a uniformity in both the jars. And now the colored vapor is uniformly distributed. And the composition has become uniform in both the jars. Now the process of diffusion gives you two conclusions. These are the two conclusions. The first conclusion is matter is made up of tiny particles. That's why Brownian motion, again we are coming to it. And these particles are constantly moving. Thus we can see the diffusion, the process of diffusion. Now pollen grains. Robert Brown is a scientist who has conducted this experiment by suspending the small pollen particles in water. So small pollen grains, they are microscopic particles. You just actually cannot see the pollen grains, but when they are suspended in water and you observe the phenomena under a microscope, this is what you observe. You see that the pollen particles are randomly moving and there is no definite pattern to it. The movement is chaotic. The movement is continuous. The movement is zigzag movement, as if every particle is bombarding against each other. And why? Because these pollen particles are so small that they collide with the particles of water. So water is matter, pollen is matter, both are made up of particles and both are in motion. Because matter is made up of particles, hence pollen and water is made up of particles. Matter is made up of particles that are in constant motion. So pollen grains are also in constant motion. Water is also in constant motion. Two moving particles. What will happen? What will happen is a doom. What's that? Collision. One colliding against another and changing its direction. And so what happens? The movement is a chaotic movement, which is known as zigzag way of moving due to the bombardment of the tiny invisible particles. And the movement of the pollen grains on the surface of water can be explained how? Just as I said. The water, see, water is made up of tiny particles which are moving. Pollen grains are also moving and they are colliding. They are colliding, bombarding. And thus you can see the random movement under a microscope. This is known as Brownian motion or Brownian movement under the name of the scientist Robert Brown. Brownian motion is not limited to this experiment because this was the experiment from where the concept was obtained. But that doesn't mean only solid and liquid. Brownian motion in general means a random zigzag movement, bombarding of the particles, collision of the particles. So here it can be observed amongst the particles of gases as well. Don't you see that in the morning when you open the window and you open the window, not the entire window, a small part of it, and you allow the morning sun rays, the sunlight to enter your room, don't you see that the path contains some particles of dust which you can see is moving? You close the window, don't allow the sun to enter, the sunlight to enter. So what happens at that time? You will see you're not able to see the particles. Now when you are opening a small part of the window and you are allowing the beam of light, the small part of the light entering through the slit of the window, then you can see the suspended dust particles. What happens? Why are they moving? These dust particles are actually suspended in air, and air is made up of gases. So air contains gases which are in motion. So these are also matter. Dust particles are also matter. Both of them contain particles and both are in motion. When they collide amongst each other, they are hitting each other. You can see the motion which is termed as Brownian motion. Moving on to characteristics of particles of matter, there are 4 characteristics. The particles of matter are very small and they have spaces between them. They are constantly moving and they attract each other. So these are the things that we can see very nicely over here. So what it is, they are very small. They have spaces between them. They are constantly moving and they attract each other. So we have evidences in order to remember, in order to understand these properties, these characteristics. To understand that the particles of matter are very, very small, we have this simple experiment over here where a deep purple color of this concentrated potassium permanganate solution is taken. So what happens is, see, if you can understand that the color of potassium permanganate, and I told you what is potassium permanganate. Potassium permanganate is KMnO4. This is the formula. So you should be accustomed to see and use this formula. Write in words, but know at least that it is KMnO4. So potassium permanganate has a purple color or has a pink color. This thing I have said previously also. What is the difference between a pink color, purple color, light pink color, lilac color? These are all shades of pink. But the moment I say deep purple color, that means the color is very deep and it's dark. So when I dilute it, what is the meaning of dilution? Dilution means adding water. So if I add water gradually and I add say same amount of water, say I'm going on adding 10 ml of water each time, then the shade of this solution, the color of the solution is becoming lighter and lighter. So when it is becoming one shade lighter, finally when we reach to this state where we can see very, very faint color, very, very light color of this pink or purple shade, and we will say that yes, this solution contains particles of potassium permanganate. Otherwise, when we are mixing, when we are adding water to it, it wouldn't have remained. Since it is so small, it is remaining after several times of dilution. So this proves that the particles of matter are very, very small. Matter is made up of particles that though we have seen before. Now these particles are very, very small in dimension. After this, we will have to see the next characteristics which says that the particles of matter have space between them. So there are spaces. This experiment we have discussed before also, dissolving sugar in water. What is happening? I have asked you, where does the sugar go? The sugar doesn't go anywhere. The sugar remains there only. But where? Where is it seated? It is seated in the interparticle space of the liquid, the interparticle space of the water. And now, whatever was the level of the liquid in the beaker where you are dissolving the sugar, you will see there is almost no change in that level. The level is remaining same. This level is remaining the same in all the three beakers. So that means that it is not adding on to the net volume, but it is just occupying the interparticle space of the solvent, that is water over here. So next, now here this thing, the highlighted part, the fact that there is no change in volume on dissolving sugar in water tells us that there are spaces between the particles of water. The particles of matter are constantly moving. We have talked about diffusion. We have talked about Brownian motion. These are some examples which explain diffusion, which explain Brownian motion. See, when you actually go to a temple or maybe even at your home, you have seen incense stick having a smell. You just put the incense stick in one corner of your room. What happens is you see that the entire room is filled with the fragrance. If you have used room freshener, you just give it a spray. After some time, you will see that the entire room is having a fresh smell. Why? You have just, sprayed it maybe on your curtains, maybe on any corner of the room. Then why does the entire room get the smell? Because of the process of diffusion. Your room freshener or your the agarbatti that you are using, that contains matter. See, agarbatti mein what I'll say is, when you burn the incense stick, it produces some gas, and these gas have the pleasant smell. And gas is particle. That means it is made up of particle. The particles are constantly in motion. And when it is going to the air is also made up of particles, and there is constant motion of the particles of air and the gases that are obtained from the agarbatti, and these particles collide with each other. Because of this kinetic energy generated because of the movement of the particles, the smell or the fragrance of the incense stick, be due to the movement of the particles of the gases, are spread throughout the room, in the whole room. Same with the room freshener. The material that is present, the aerosol that is present in the room freshener, when you spray it, it contains suspended particles. They get spread out, diffused, and so you get the smell. Next, we can see the process of diffusion of copper sulfate in water. Copper sulfate has a blue color, as potassium permanganate has a purple color. The crystals of copper sulfate are blue in color. Now, when you keep those crystals of copper sulfate in water, after some time you will see that the entire water is getting the color of the copper sulfate and is becoming blue. Now, this process may be slow without an external agent, but will occur. Now, if you go to stir it or if you go to heat it, the process becomes faster. The rate of diffusion becomes faster. So, the rate of diffusion depends on factors like temperature. Okay, depends on factors like the kinetic energy of the particles. Why? Because when I'm stirring, I'm increasing the kinetic energy. When I'm heating it, I'm increasing the temperature, and thus the process of diffusion becomes faster. So next, the particles of matter attract each other. Yes, we know that solids have a definite shape. So in solids, the particles are tightly packed. They are closely packed. They are having a definite structure, a definite pattern of arrangement. But not all solids have same type of pattern. Yes. So the particles of solid also have different types of structure. Here that I was going to show you. This is the one having a definite pattern, right? So if it is having a definite pattern, this type of solid is known as crystalline solid, And if it is not having a definite pattern but is a solid and has a powdery appearance, is known as amorphous solid. Like if I say sugar is a solid, talcum powder is also a solid. But do they have same type of appearance? No. Sugar has a particle-like appearance, crystal-like appearance, because it is crystalline. And why is it crystalline? Because it has a definite structure, definite arrangement of the particles of solid. But in case of talcum powder, it doesn't have a definite arrangement, a definite pattern, maybe haphazard in this manner. So this is for amorphous and this is for crystalline solid. Both are solid, but different manner of arrangement of the particles. Moreover, I will use a term called cohesive forces and cohesion. That is the type of forces existing. Co means what? Co means same. And cohesion means same types of forces of attraction. That means the forces of attraction between the particles of the same substance. Then only the forces of attraction will be of the same kind. So that is known as cohesion. Any solid, any matter will have forces of attraction between its particles, be it solid, be it liquid or gas. Maybe the forces of attraction are not to the same extent. In case of solids, the particles are tightly packed because they have stronger forces of attraction. The cohesive forces are stronger. And so they are rigid in form. They have a definite structure or definite form. That is the reason behind these properties of solids. Now see chalk, ice and iron nail. You go to hammer them. Which one will break first out of chalk, ice and iron nail? I think most of you will be guessing it correctly. Yes, chalk. Why? Because the arrangement of the particles are not same in all types of solid. Iron nail have a rigid or strong arrangement of particles which is not happening in ice or chalk powder. Chalk exists as powder. So it also exists as chalk pen. So when you break them, it forms a powdery form. So forces of attraction is maximum in particles of solid and moderate in particles of liquid and minimum in particles of gases. Why? Because particles of solid, they are tightly packed. I have showed you this also. So this is the particles of, I can say it's of solid. Liquid particles are actually having a little bit of gap between them. The gap is greater than the solids. And in gases, oh my God, the movement of the particles are so random, like your movement in your school whenever there is no teacher. So it becomes what? Gas particles are moving randomly. Liquid particles are having this movement, but it is not as random as gases. And solids are tightly packed because these particles are having stronger forces of attraction between them. So this leads to the property of fluidity to that of liquids as well as gases. That is, liquids and gases have a property to flow, which is known as fluidity. So gas is also a fluid and a liquid is also a fluid. But let us see them in little bit details. Rigidity is a property that is going with the solids. Why? Because the particles are closely packed particles. That means I am writing here the particles are closely packed. Okay. For that, what happens? There is maximum forces of attraction. Maximum forces of attraction between the particles of solid. That gives a rigid form to it. And so it is not compressible, not flexible, and hence it is rigid in form. Fluidity means the particles can flow, can move. Why can they flow? Why can they move? And why are the solids not moving? Now you may say, ma'am, a ball is rolling down. Dear, rolling of a ball and moving of the particles are not same. When you are talking about rolling of a ball, the entire object is moving. And when I'm talking about moving of the particles, I'm talking about the particles inside the ball. So the ball has a definite structure, right? It's a spherical structure. Can I say the liquid is rolling? I can never say the liquid is rolling. I can say the liquid is flowing. The gas is flowing. Why we are using these different terms? Because of the different forms of solid, liquid and gases. Now the liquid is flowing and the ball is rolling. Why? Because the ball is rigid in form. The particles are closely packed. They have maximum forces of attraction between them. Whereas a liquid or a gas have lesser forces of attraction. So I'll say moderate forces of attraction in liquid and minimum forces of attraction in gases. And so they are free to move around. So they are moving out and they are diffusing out easily. But keep in mind that when you keep a liquid in a container, say you are keeping a liquid in a container which is open, the liquid will occupy the lower part of the container. It is not that if you keep a glass of milk, the upper part of the glass will have the milk and the lower part is vacant. It can never happen. So if you keep a glass of milk, the bottom of the glass only will be having the milk. So, if you keep it open, after some time, suppose your mother has given you a glass of milk on a table and is telling you to drink it fast. If you come after 1 minute, will you go and see the milk has escaped? No, not at all. But if you keep gas in open container and you go, you will see that the gas is not there. It has already escaped. Why? Because these gas particles are even more free to move around. The particles have minimum forces of attraction. So liquid will not escape easily from the open container, and mark my word, I have said easily. That means if you keep the liquid day after day and year after year, don't expect it to be remaining there, no, because of the phenomena of evaporation. So we are not going to that type of phenomena right now. But we are going to the fact that a liquid kept in a container will obviously possess the shape of the container. A liquid doesn't have its own shape. It attains the shape of the container because of this property of fluidity. But if you keep a gas in a container, that will also take the shape of the container, of course, because it is occupying. But you can compress and keep more and more of gas in the container. So what happens is the volume that you are using is the volume of the container. In the case of liquid, what is happening? See, compressibility, if I compare, suppose I am comparing properties like rigidity and I am comparing properties like compressibility, and I am comparing the property of fluidity with respect to solids, liquids and gases. So solids will have maximum rigidity than liquids, than gases. Because of what I said, the particles are closely packed and have maximum forces of attraction. Go to compressibility. Gases are highly compressible than liquids, and of course solids are almost, I will say, incompressible. Go to fluidity. Gases are having more fluidity than liquids, and go to solids, which are not having the property of fluidity. So next, moving on to the next here, classification of matter as solids, liquids and gases. So here, properties of the solids, we have explained that it has a fixed shape, fixed volume, cannot be compressed, have high density. Why? Because of the close packing. Do not fill their container completely and do not flow. I think I have covered up all the properties and the reasoning in my discussion. Next, moving on to the properties of liquids. They have fixed volume but have no fixed shape. Liquids take the shape of the container in which it is kept. They cannot be compressed much. So mark this word, much. That means they have compressibility but not as that of gases. They have moderate to high density, but it is of course less dense than solid. Liquids are having the property of fluidity, right? It's having the property of fluidity, and so it can flow easily, but not as gases. So gases are, see, properties are such that solids are in one extreme and gases are at the other extreme. In between are the properties of liquid. So liquid have all the moderate properties, not as much as solids, not as much as gases, but something in between. So properties of gases are what? They have neither a fixed shape nor fixed volume. Liquid did not have a fixed shape, but it had the volume. But gases doesn't have the fixed volume as well. They acquire both shape and volume of the vessel where they are kept. They are highly compressible. Why? Because the particles have lot of interparticle space, maximum interparticle space and minimum interparticle forces of attraction. They are not held tightly. And for this very reason, they have low densities as well. They do not have a proper definite packing of the particles. They fill their container completely. Of course, it should be closed container. Otherwise, it will escape out. So the process which I said, escape out, is because of its fluidity, and so they flow easily. Why solids, liquids and gases have different properties? Because of the different arrangement of the particles, because of the different energy of the particles, that is kinetic energy of matter, kinetic energy of the particles. So according to the kinetic theory of matter, the particles of matter are in continuous motion, and the energy on account of motion is termed as kinetic energy. The forces of attraction existing between the particles of matter are not same. So they are termed as interparticle forces, and this interparticle forces of attraction is maximum when the particles are tightly packed, which occurs in solids, and is minimum when the particles are extremely loosely packed, which occurs in gases. Now, can you bring the particles closer? Can you reduce the movement of the particles? Can you reduce the kinetic energy? As we know that increasing the temperature increases the randomness of the particles and hence increases the kinetic energy, we can say that if kinetic energy of gas particles are maximum, then if I increase the kinetic energy then of the solid particles, I may go to the liquid state, and if I again increase the kinetic energy of the liquid particles, I may go to the gaseous state. If I decrease the kinetic energy of the particles, I can come down to a liquid state, and again if I decrease the kinetic energy of the liquid particles, I can reach a solid state. So this is actually change of state which I am talking about. The following properties of particles decide whether a given substance can exist as a solid or a liquid or a gas. What is that? Interparticle space. If the interparticle space is minimum, it is solid, and maximum, it is gases, and moderate in liquids. Interparticle forces of attraction. If space is minimum, obviously the forces of attraction will be maximum for solids and minimum or negligible for gases. Amount of movement or kinetic energy of the particles. If I don't have, you enter a bus which is packed with passengers and you are struggling to get in, can you move around? So that happens in a closed packed structure of solid. The kinetic energy of the particles is minimum because the particles are not able to move. And you enter a free, say a bus which is not having much passenger, at that time you take much time to get seated. You choose your best seat, you change the seat again and again because you're free to move around. That happens in gases. The movement is maximum for gases because the kinetic energy is also maximum. The particles are moving randomly. So solids, that is what I have seen. In solids, the particles have fixed shape. Why? Due to the closed packed structure, due to the strong forces of attraction between the particles. They have fixed volume. Why? Because their structure is rigid, the space is minimum, and it has a fixed pattern of arrangement of the particles. They are not compressible. Why they are not compressible? Because the particles are closely packed. Where? In solid. They have high density. Because again the same reason, close packing, less gap between the particles, so density is very high. They do not fill its container completely. Why? Because of the strong interparticle forces existing between them. So they cannot escape that layer, no, the solid particles. So they do not flow also like liquids and gases because of the strong interparticle forces of attraction. Now, then you can say, ma'am, there is a rubber band, it has flexibility, then how can it change its shape? How can it stretch? Every solid have different flexibility. Some are highly flexible and some are negligible, have their flexibility to the negligible extent. Now a rubber band is a solid because it changes its shape under the action of force. It stretches. When the force is removed, it again goes back to its original shape. Like all other solid, the rubber band can be stretched under large force. When you see your mother making a dough, doesn't the shape of the dough change? So will you say that, oh, it's flowing and it's a liquid? No, it's a solid and it is changing its shape with the application of an external force. Next, we go on to the next page over here where liquids we can see. Liquids, the particles are close together but not as that of solids, and they are having intermediate properties. That is, they are not having any fixed shape. Why? Because the positions of the particles are not fixed due to its comparatively less forces of attraction between them when you are comparing it to that of solid. A liquid is having lesser density than that of solid but greater than that of gases, and comparatively high density because the particles are still quite close together. That means why I'm talking about comparatively high. Comparatively high means greater than that of the gas particles. Now, to show that liquid do not have fixed shape, see, same amount of liquid taken in different vessels have different shape. So I can keep the amount of liquid same. I can take 50 ml of water and I can take it in a beaker. I can take it in a conical. Say this is a beaker and then this is a glass tumbler. This is a conical and this is a flat bottom flask, or say a volumetric flask. But the capacity may differ, the shape may differ, but I have taken say 50 ml only and I have taken in all the three containers, but it is looking different because the liquid doesn't have its own shape. It takes the shape of the container. Next, this is the point which I have told and I am highlighting the same. Next, moving to the next page, let us see gases. The properties of gases: particles are very, very far apart, minimum forces of attraction. So the particles of gas, they have what? Negligible force of attraction, minimum. Okay, so they have maximum distance, I'll say, apart. Now they have maximum interparticle spaces. So see, spaces of the particles are not fixed also, and they are maximum apart. They move at a maximum rate, have maximum kinetic energy. See, if it can move randomly, that means the forces of attraction are negligible and hence the kinetic energy. So high kinetic energy and negligible forces of attraction, that gives high speed to the gas particles, that gives maximum fluidity to the gas particles. So again, we can see the properties. A gas will not have a fixed shape. Why? Because it is not having the fixed position of the particles. It doesn't have a fixed volume because the particles are not fixed. Now the gas can move anywhere and so it can be compressed easily. It has very low density and it has maximum fluidity. So this is one activity to show that gases do not have fixed shape. You fill fixed volume of gas, say in different shape of balloon, a round shaped balloon, maybe a long shaped balloon. You see that the gas is actually seeming to have different shape. It is not the shape of the gas but the shape of the balloon itself. To show that solids and liquids cannot be compressed but gases can be compressed easily. We can use a piston, we can use a syringe. You know, a piston works like a syringe, only it's the same thing. In a syringe we have this type of thing which is used to compress it. Now you take a syringe and common salt, say solid. You take liquid and you take gas, and when you are compressing it, you will see that you are facing difficulty in compressing the solid. You are not able to actually change the position of the piston or bring a change to the level of the solid. But in a liquid, maybe you are able to bring little bit change in the liquid level, and in case of gas you can see that the particles are coming so close and highly compressed. So compressibility factor is there in liquid and gases, but the compressibility factor is maximum in gases because the interparticle space is also maximum in the gas particles. So you can bring them closer by application of external pressure, external force. So this is what is seen. A solid does not get compressed on application of the pressure. A liquid does not get compressed on application of pressure. But here I will mark that liquids have some sort of compressibility factor, little bit also. You cannot totally rule out. You can say not as that of gases, but it is having in between solid and gases. Maybe the compressibility factor is very, very less. A gas is highly compressible on application of pressure. If you give same amount of pressure, maybe you will see huge change in gases and you may not be able to see the change in solids and liquids. Now gases have high compressibility. Example, the true life example is what? Your LPG cylinders at home. Don't you see the cooking gas? That is liquefied petroleum gas. That is what? At your home, where you see that the gases are kept in a compressed manner. CNG, what is CNG? Compressed natural gas. Why compressed? Under high pressure it is being kept. So these are the two examples. CNG, where is it used? Compressed natural gas, where is it used? In vehicles like cars and buses. Now diffusion process, we have discussed intermixing of particles or spreading out and of particles due to the capacity of movement of the particles or due to the kinetic energy of the particles. So random intermixing of particles on account of its kinetic energy, on account of the motion of the particle, is termed as diffusion. And diffusion can take place in solids in liquids, liquids in liquids, and gas with another gas as well. So of course I will add on, gases are more diffusible than any other form. Okay, so diffusion is a property of matter which is based on the movement of the particles. Since the movement of the particles is maximum in gases, diffusion is fastest in gases and slowest in solids. On increasing the temperature, the rate of diffusion increases. Why? Because on increasing the temperature, the kinetic energy of the particles increase, and hence they can diffuse with a greater speed. So rate of diffusion depends on type of material, type of particle. So gases will diffuse faster than liquids, than solids. And also it depends on the temperature, because this is related to the kinetic energy of the particles. Light gases diffuse faster than heavy gases because again it depends on density of the substance. So if you have seen in a race course, a person who is very fat finds it difficult to run than a person who is very thin. Now here, because of I am comparing it to the density of the particles. If the density of the particles are very high, then the rate of the diffusion becomes slow because the kinetic energy becomes slow. The smell of food being cooked at the kitchen reaches faster and to longer distance. Okay. So now you can see these are the examples of incense stick. I have already used this example. Smell of perfume. Now leakage of LPG in your home is detected. Why? Now here it is detected due to the diffusion of a strong smelling substance. You know what substance is added? It is ethyl mercaptan added in order to detect the leakage. Otherwise, anytime accidents can cause. You may have seen that you can say that I'm getting the smell of the gas. That means something is wrong. Open the windows such that the gas can diffuse out. Here again is the process of diffusion. The gas can diffuse out, or you can just switch off the main cylinder. That's the safety measure, I will say. But what substance is added to it such that you can get the smell? Ethyl mercaptan is the chemical that is added in order to detect the leakage in LPG. So diffusion in liquids here is slower than that of gases, of course, because the particles are not as free to move. So it is slower. So the crystal of KMnO4 remains at the bottom of the beaker, takes time to make the entire solution pinkish or purple in color. But if you heat it, you will see rate of diffusion becomes faster. Same with the crystal of copper sulfate kept in water. Same is with the ink spread in water. So here's something I will say. The gases like carbon dioxide and oxygen are essential for survival of aquatic plants and animals. The carbon dioxide gas and oxygen gas present in air or atmosphere diffuse into water, where water bodies like ponds, lakes, rivers, and they are dissolved. Have you heard about dissolved oxygen? The amount of oxygen that is dissolved. Have you heard about the survival of the aquatic plants depends on this biological oxygen dissolved in it, BOD. Okay, so the aquatic plants use this dissolved carbon dioxide for preparing food by photosynthesis, because you know that plants require carbon dioxide for the process of photosynthesis, and animals require oxygen for their respiration process. So aquatic animals, they get the oxygen from the dissolved oxygen in water. This is an example of diffusion of gases in liquids. In fact, solids, liquids, as well as gases can diffuse into liquid. This I have already mentioned, that solids diffuse into liquid, a liquid will diffuse into liquid, and a gas will also diffuse into liquid. The rate of diffusion in liquid is much faster than that in solids. Why? Because of the movement of the particles, which is restricted in solids. Now, diffusion in solids. Let us see this part once. Diffusion in solids. We know the process should be very, very slow, because the tightness, the rigidity of the liquid particles. Okay, so if we write something on the blackboard and leave it unclean for maybe some days, don't you find it difficult to erase it, to rub it? So why? Because the chalk particles has undergone diffusion. Maybe very slow, but yes, it has undergone. Two metal blocks are bound together tightly, kept undisturbed for a few years. You see that what happens? Almost they stick to one another on account of diffusion that has taken place. So the diffusion of a solid substance into another solid is so slow that many people think that diffusion does not take place in solid. But the process is not visible so nicely as in liquids and gases. But yes, the everyday experience of chalk and duster, that is your blackboard, that I think, yes, all of us has experienced. These are some practice questions which you can practice, and I think most of the questions, the answers to the questions, you will get in the video if you can view and listen to the entire part of the video.